able to see this screen?
Yeah. Yeah.
Here you see, the first, in the last class, we saw about dy by dx. Just it is like a chain rule. Do you remember it?
Yeah.
What does mean by chain rule? First, you want to take care of the outermost function. Then it, then you want to go for the okay. So only here we doing like this dy by dx, and then here it is in the denominator. First I am taking to the numerator, then I am differentiating the powers first. So this -4 will come to the front, and then the -1 it become -1. After that you want to do the differentiation of inner function. So here I'm differentiating. So final answer is this one, right?
Yeah.
Uh, then we saw about the gradient, right? So the gradient is nothing but slope. That means here if you have a line like this, landing, how much it is sloped. So if you want to check that, then you want to go for okay. Actually, the tangent is a line. It's a straight line. It touches only the curve. And if you go there, what will be the one point? It will be like this, but never touches this lines, never cuts any curve except that one point. So that is what we call tangent. Okay,
Yeah.
can you able to recall it? And then the formula to find out the gradient and tangent is dy by dx at the point uh, at the point x1 comma y1. Yes, so here the one problem we solved. The next problem, two problems only we solved it in this class. So what is the gradient if they ask me? And then in that, from that equation you want to find dy by dx. Okay,
Yeah.
uh,
Is
m is
M?
equal to dy by dx at the point. So here the point is given, so just if you substitute you will get that. That's
Okay.
all your answer. Okay, and here also the same thing, they ask you to find out the gradient for, but the usually what is the formula to find out the slope? Dy by dx at the point, right?
Yeah.
So I need 1 point. Am I right? I
Uh,
need 1 point. So what is that 1 point? Because if you know the curve, find out dy by dx. But if you want the if you want you want to find out dy by dx at x1 comma y1. Is it okay?
yeah.
So if you want to find out the gradient, then I need dy by dx and also x comma x1 comma y1. Okay.
Yeah.
There you see there is no point. Am I right?
Mm-hmm.
So if you don't have a point, that may given some clue. From that clue, try, you want to find out the value of slope. Okay. So for that, what you are doing, actually, we are go from back to the formula. What is the slope formula? Dy by dx at the point what? 0. Yes.
Yeah.
Ah, to find out this point, this 2 comma 5 or something else, we don't know, no. So to find out this point only, we have the So here you can see, if you solve these two equations, you will get the intersecting point. That intersecting point, in that intersecting point only the tangent are moving. So here find out in dy by okay, here we find. Before that, if you want to need the point, then you want to solve these two equations. Isabel, are you here? Isabel?
Yeah.
Whether this question we discussed in the last, or else you need from the beginning.
I'm a bit confused what we're trying to do. Like, what's the gradient exactly?
Gradient, are you clear about the concept of gradient?
No, not completely.
Not completely. Okay. Okay, we will do it once more. These two problem.
Okay.
Is it fine for you?
Yeah, it's fine.
Okay. I will do it once again, this problem, so that it will be understandable to you. So the gradient, do you understand? First of all, just a definition. Like a definition, did you understood?
Not completely.
Okay, okay, fine. I will teach you once again. It's not an issue for me, but try to understand me. I'm trying to take that question once again, so that that question and paste it here. Copy. I will share another screen. Okay.
Okay.
See here in the question, they're asking for what?
The gradient.
The gradient, and first of all, the concept of gradient you understood, okay? Line is, if it is then x-axis, y-axis, and something else. If you have a line like this, okay? If you have a line like, if you want to make an equation, then first the concept is how much it is, okay? How much from the baseline. If it is the straight line like this, it is like an initial line, okay? They all other position is we call as an slow a line, that's all, straight line, okay? And
Yeah.
then the slope is how much it is slanting. See, this is not, so here slope will be 0, for horizontal be 0. For this line, how much it is like obtuse angle or that, right? So this is what we call it as a slope. Okay, how much it is slanting from the initial. Okay, okay.
Yeah.
And